All right. Hello, everyone, and welcome to hardware hacking. So, because of certain kind of lockdown slash pandemic, um, unfortunately, we're not able to have like in-person hackathons. So, we're gonna do the next best thing, which is make hardware online or virtually. Thankfully, we have some emulators and we have some web-based platforms that allow us to work with microcontrollers online, and we can have um, different types of hardware setup, programmable hardware setup that we're gonna touch on today. So just a quick just a quick FYI. If you have any questions, please feel free to just ask the questions. I will be answering them as I see them. Um, okay, so let's get started. Okay, so the first thing you guys want to do is go to a website called Tinkercad. So that's Tinkercad.com. So that is basically a website that'll take you to this kind of interface. Actually, I'll log out and I'll show you how. So let's go to Tinkercad. So when you go to Tinkercad.com, if you don't have an account already, you can join now, and then you can create a personal account, sign in. Um, of course, if you have an account already set up by your class or whatever, you can join a class. But in that case, just sign in. So I already have an account, so I can sign in with my Google ID, and yeah. So once you sign into Tinkercad, we are going to look at how to build electric circuits and programmable electronics in Tinkercad. Okay, so the first thing you want to do, Tinkercad is a platform where you can do many things like uh, create 3D models, create designs for actual hardware, things that you can export and print on a 3D printer. But today we're going to look at circuits. You're going to go ahead in Tinkercad and click on circuits. And here you're going to see, basically, if you've done this before, you're going to see like a bunch of circuits here. But if you don't see this, that's fine. You can go to create new circuits. And what that's going to do is it's going to give you a list of things that we can create. And of course, we can create your basic battery, switch, light. But today we're going to go with a microcontroller, the most commonly used programmable microcontroller, which is an Arduino. So you can drag the Uno from here onto the main canvas. And I'm going to talk about the microcontroller a little bit, and then we're going to go into building some basic circuits and some pre-built designs as well. So this is what the Arduino Uno microcontroller looks like in real life. So if you have an Arduino or if you have a kit, this is essentially what it looks like. And you can see it's arranged in a certain way. We're going to go over very quickly what these things are. So the actual processor is this rectangular little chip over here, and that's basically what you're programming to do certain things. So we have these rows of holes or ports. We have oops. So we have these this little row over here, which is the power slash signal row. This row of pins or holes are for analog inputs. Um, the top row are mainly for digital inputs, and there are some special sets of pins, which are called pulse wave modulation or PWM, but we're not really going to go into that. So basic idea: digital, analog, power. There are also two very important pins here or important holes here that you need to be aware of, which are the ground holes. So you see there's a GND that essentially stands for ground. So you see there's 2 grounds at the bottom rail and 1 ground in the top rail. Okay, so before we go into building circuits and stuff, let's take a look at how we can program this microcontroller. If you're going to program this microcontroller, the most basic program you can write on here, there's a built-in LED, and the built-in LED essentially has functionality that turns it on and turns it off. And this is the most simple program you can write. So if you want to program this, what you want to do is essentially hit code with your microcontroller, and it's going to bring you to an interface that looks like that. And this is the blocks interface. So it's fine to program in blocks if you're not familiar with C notation. So just FYI, the Arduino microcontroller is programmed using the C language. So that is that's basically like a very low level language, and it's not as intuitive as JavaScript or Python, but for what we're doing, it uses very simple structure. So you'll find it I hope very convenient. So you can program it with these blocks. So these are basically like logical blocks, but let's not do that, and let's go to text. So text, and voila, here is a typical program that will run on the Arduino. So the structure of this code always follows this kind of format. So right now we're not importing any libraries. We're just using whatever's native to the Arduino. That's fine. We're not using any definitions. So what we want to do is we want to see how this is structured. So every piece of Arduino code has to have these 2 sections. There has to be a section called setup and another section called loop. So what this does is whenever there's an Arduino with some code loaded on it or code burned on it, the setup section runs once, and then the loop section essentially runs continuously. So this is basically a loop that runs forever, and it's going to do this process. Like it's going to continuously do this process. So this is how Arduinos are programmed. Okay, so without further ado, let's just jump right in and see what this code does. So if you have some code here and you have the Arduino attached on your circuit, and you're pretty certain that your code works, you can go to Start Simulation, and then you'll see Initialize. And what's going to happen on your canvas is you're going to see the Arduino is going to get some power. So this basically allows power in. And first thing you'll notice is the light turns on and the LED starts blinking. So let's now inspect what in this code causes this behavior to happen. First of all, when you run the simulation, you are going to power up the Arduino. If your wiring is correct, this little light is going to turn green. Okay, then let's take a look at the code. So in the code, first, there's a line that says pin mode 13 output. So what that tells us is configure port 13. So here, this is port 13 to be an output port. So the way you program these pins are you have to configure them to be either input or output type of connections. The port 13 is kind of special here because port number 13 is internally connected to the built-in LED. So whatever you do to port 13 as output is going to be reflected in this little internal LED. All right. So we set up port 13 to be output. And then in our loop, we say digital write 13 high. So this means I am writing a signal that's A digital signal essentially is either a 1 or a 0. So when I say digital write high, it means I'm writing a 1 to port number 13. So writing a 1 to port number 13, and then this piece of code, which is delay 1000, means wait for 1000 milliseconds. So essentially wait for 1 second. So you write a 1, wait for 1 second, then you write a 0 and wait for another 1 second. So let's take a look at what happens if we change this to some other kind of behavior. So we make it 500, and we make that guy 500 also. We're gonna see that. Can I zoom in a bit? That better? Okay. And where did I click to get into the code section? Okay. So when you're like this, you click code, and then here you click text, and that gets you to the code section. Okay. Yeah, sorry about that. I just saw the question right now. Okay, so here, if we change this to 500, let's start the simulation and see what happens. As you can see, the LED blinks considerably faster. And we can stop that simulation, and let's say I want to change this to even faster. Let's say 200 and another 200. And that is going to make the LED blink even faster. So effectively, what you guys saw right now is how we can use the code interface to interact with an Arduino, which is based over here. All right. The one thing you can do when you're working with Tinkercad is if you have a real Arduino, you can actually, like, once you set up your code, you can actually download the code, and it's going to download an INO file. So if you've worked with an Arduino before, you know what an INO file is. This is the file that essentially can be loaded onto your actual Arduino. So if you go open up the Arduino IDE and open that file that was downloaded, it's going to load right into your actual Arduino. Okay. Now let's start to do something fun. Let's not have code, and let's do a. Let's pick a circuit. All right. So let's say I want to actually do this guy. You can actually have multiple Arduinos. So let's get rid of this guy. I'm gonna hit delete. Actually, I'll just hit delete to get rid of this guy. So you can't see this on my keyboard, but I'm going to do that guy. All right. So if you go to starters, you're gonna find a bunch of kits. So this is the same Blink program, except except here we have a real LED connected with a wire and a resistor. The reason we have a resistor is because we don't want the LED to burn out. In a simulation, it's not going to burn out, but in real life, it's always a good idea to have a resistor that limits the amount of current that your LED faces. So here, we're going to see the same Blink code. Look at the code and go to text. And we're going to see here, this is the same Blink code that ran previously. Start the simulation. As you can see, the LED starts blinking, and it's actually blinking the LED synchronously with the built-in LED. So that's how we make an Arduino blink and an Arduino work um, on Tinkercad. All right, let's start to do something a bit more involved. All right, let's get rid of that. And let's do a button. This. Okay, so here we have what is called a push button. So again, if you want to get any of these components, you can go straight to all, and you can search for a number of different components. So these are all things you can connect on your canvas, and there's your usual breadboards, batteries, servos, motors, LEDs, um, uh, distance sensors, etc. There's also some fun ones. I think there's like a lemon battery, so that's something fun, or a potato battery you can try and work with. And there's your usual chips and different types of quad gates and whatnot. All right, but we are going to stick with this guy. All right, so this is a push button, and what this does is this essentially allows you to have an external input to your Arduino. So we've seen how the Arduino has an output where you can blink a light or blink an LED. Now let's see how we can feed an input. So the simplest input is we're pushing a button. Is the button on or button off? Let's take a look at the code. Oh, or before we take a look at the code, I'll just explain how this circuit works. So when you have a push button, you need to connect one end of the push button to ground and one end of this push button to the 5-volt line. So what happens internally is when you push this button, the circuit between the 5-volt and whatever other pin is connected is completed. So when you push the button, this circuit is basically bridged. And when you don't push the button, then the circuit is this circuit is open and it doesn't get it. All right, take a look at some code. Go here, go text, and this essentially is a system for detecting state change. Okay, so before we look at the code, there's something new here that you need to kind of know, which is this line right here that says serial begin 9600. So the way the Arduino can communicate with the outside world, apart from sending a signal on one of its pins, is actually when you have a serial port or this guy connected to your USB. This is actually a serial connection. So this interface can send things like strings, things like numbers, integers, strings, and even like raw bytes. So in order for us to access the serial port, in the setup, we need to initialize the serial library by saying serial.begin, and this number essentially tells you what the speed of the serial port is going to be. So here it's 9600, which is the default for Arduino. 9600, this is the baud rate, or roughly bits per second, but the Arduino actually supports higher and lower bit rates, but this is basically the number that's the default for the serial. Okay, so what we're going to do here is we're going to store whether the button was pushed or not in an int. So we're going to declare int button state is 0. And then we are going to store the previous button state also. And we are going to have a counter a variable that kind of counts how many times was the button pushed. So we set up pin 13 as output just to show us an LED. We set up pin 2 as input. As you can see, the button is connected to pin 2. So this is an input, and it's the digital input because top rail is digital. And in our loop, here's our logic. So if statements are like Java and C and C, like if statements in C are almost exactly identical to how they are in Java or in C++. So this, if you guys know those languages, it should be pretty familiar to you. So the first thing we do is we read from pin 2 what the button state is. So that's the current button state. So remember, the digital pins can basically either input or output high or low, and that's a 1 or a 0. So by default, they're all low. And if we say button state is digital read 2, that means read from this pin. And if the pin is high, then button state becomes 1. So if the button state did not change, which means it's a different or it's a new button state, then we increment the counter. So if the current state is high, then basically it was off before and now it went to on. And then we are going to serial.println. So the println from serial essentially gives you output to the serial monitor. And we're going to print out the number of button pushes. And this is the button push counter. So we increment the button push counter if it goes from off to on. So essentially, if it was low and it became high, then we increment the button push counter. Otherwise, if it was high and it went to low, we print off, and then we delay 5 milliseconds to avoid debouncing. Debouncing is essentially a way to make sure that there is no residual current that interferes with your signal. And finally, we save the button state as the last button state. So this is the previous buttons. We're saving the previous button state for the next time. And every time we have a multiple of 4, so every 4th button press, we're going to turn the LED on. All right, that's enough explaining the code. Let's run this guy and see what happens. So you see the LED is on because 0 is a multiple of 4. I press it 1, 2, 3, 4, and then turns on. All right. Now, remember we said that we are actually printing these things out. There's a way you can see them. So if we start the simulation again, now before you do anything, you see there's a little thing called serial monitor here at the bottom. That and it's going to bring up the serial monitor. As you can see, previously it said off and 4, so we can clear it. So right now, it doesn't say anything because it's the current state. Tinker 1, number of pushes 1. And I'm holding the button down with my mouse. If I leave it, it goes off. And here the LED turns on. So this kind of shows you how to do input of signals into your microcontroller, and also to have the serial monitor print out data or print out output that you can monitor and you can actually debug. So when you're using an Arduino, if you unfortunately don't have access to a debugger, you can put in print statements, and that's where the print statements go, and that's how you print stuff out to the serial monitor. Okay. If there are any questions, I'll take them. If not, I'm going to move on to something a little bit more involved. So let's start this guy, the code, and Wait for. Okay, cool. No questions. All right. Uh, let's get rid of that. Okay. Take a look at something a little bit more fun. Let's do a tone keyboard. Okay. So this is a way for an Arduino to play a kind of melody. So I'm not sure if you guys can hear it, but let's actually start the simulation and show you what it does. Did you guys hear that tone? Okay, awesome. You can see. Okay, so what this is going to show you is how we can actually interface with some more involved hardware setup on a breadboard and an Arduino. And this is usually when you see a circuit with an Arduino, you usually find a breadboard with some electronics on it and then the Arduino attached to it. All right, so just real quick, let's go over how the breadboard is laid out. So if you see a breadboard like that, the essential layout of the breadboard is, you see the bottom rail. The bottom rail is all electrically connected. So if you connect anything to one of these holes in the bottom rail, it means you're connecting it to any other hole in that same rail. The same goes for the black rail, and also the same goes for the top two rails over here. Okay, then what happens is, in the middle, all these little columns of 6 holes, so 6, 6, 6, 6, like all these columns, they're all connected together. So anything that's connected to, let's say, this guy will be equivalent to it connecting to this guy and this guy and this guy and so forth. All right. So the way we want, or the reason the breadboard is laid out like that, is because a lot of components need power, and instead of running like separate wires from one hole directly to everything, it's easier if you connect the power line to one of these rails, and now everything here that's connected is going to get 5 volts. Similarly, to complete a circuit, if you guys have taken electronics, we need to have a ground. So the way electrical circuit or electric circuits work is, it's a circuit, so it has to be like, whenever a current flows in somewhere, the current has to flow back. So it must finish a loop. And in order to finish a loop, you need to have a ground and you need to have a power line. So the power line connects to one of the rails, the ground line connects to the other rail. And you can extend these two by looping together with a wire this rail to the other black rail and the red rail to the bottom red rail. Now, everything that's on this is ground. Everything that's connected to this guy is power. Okay, so that being said, we also need to have, if we want to have analog inputs, we need to connect different wires to analog pins. And we have 3 different types of inputs which are connected to the analog pins right here. This component right here is a speaker, and this is connected to digital 8. So that's that essentially is the connects to one of the terminals of the speaker, and the other one is connected to the ground. So whenever this is high, and this is high at a certain frequency, that's what you're going to hear from here, from the speaker. Okay, so one thing you might notice is there's a color combination. So this is really good. It's not required, but it's really good practice, so that if your wires turn into like wire spaghetti, you'll still know what wire does what. So there's a separate color for every separate function that you do. And the standard is using black wires for the grounds and red wires for the power. Okay, we have three buttons, and all these 3 buttons complete a circuit between ground and here. So they complete a circuit to these three analog inputs. Take a look at the code. And is this a preset code that is available? It is a preset code that's available. If you go here and then you go to tone keyboard, this is the tone keyboard code. You go to code and we go to text and So as you can imagine, this requires a little bit of setup. So let's set up all the pins. So we have A0 input. So nomenclature wise, if you want the analog pins, you need to put an A in front of the pin number. So that's 0, 1, 2, 3, 4, 5, and this is A0. For these, you don't write D, they're just normal numbers. So A0 is an input pin. So all these three are inputs. So A0, A1, and A2. A0, A1, and A2 are input pins. Digital 8 is an output pin. And let's now look at what the code does. So the first thing that we want to do is we want to see if A0 is high. So if this button has been pressed, then we use this function called tone. So the Arduino has a built-in function to interact with very basic speakers called tone. And the way the tone function works is it takes in three parameters. So the first parameter it takes in is the pin number that it's connected to. So this, as we know, is connected to pin 8. The second is the frequency of the note or the frequency of the sound that it's going to play. This is 440 hertz, which if you know music, it's an A. It's actually the fourth A, which is A4. That's 440 hertz. And the duration, how long is it going to play this tone for? We can actually increase the duration to show you what happens. So let's make this like 300. Make that like 300. Like 300. And let's run the simulation. And you can see that it has a certain amount of lag. Okay. Stop simulation. So one thing you might notice is when your simulation is running, you won't be able to change the code. So that's actually also true for the real life Arduino. The code can only be changed and re-up. Like it's not a hot swap code. You have to stop running whatever you're running and re-upload code. And the reason you hear different tones is because we are changing the frequency of the melody that's being played. And of course, we put in a little delay so that there's no debounce or artifacts that you can hear. Okay, I think that brings us to the end of our workshop because it is now it's now midnight. For you PST guys, I am on the East Coast, so it's like 3 a.m. right now. So if you have any questions, please feel free to ask me. And if not, I hope you have a good time at SacHacks and happy hacking. Do I have any social media? Sure. Social media. I have a LinkedIn. I'm not sure if I can post it here, so I'll put it in. Uh, that that is my LinkedIn, and yeah, I'm happy to be of help. I hope you guys found this useful, and yeah, I hope you guys are well underway in your projects, and I wish you all the best.